In this module, you will learn how we hear sound. Most animals, including humans, hear sound through the ears. Each ear is divided into the outer ear, the middle ear, and the inner ear. The shape of the outer part of an ear is like a funnel. When sound enters the ear, it travels down a canal at the end of which there is a thin membrane which is stretched tightly. It is called the eardrum. The membrane of the eardrum is like a stretched rubber sheet which is attached at the end of the canal, connecting it to the outer part of the ear. It performs an important function. When a sound enters the ear in the form of vibrations, the eardrum vibrates. The vibrations then reach the inner ear, from where they finally reach the brain, and we are able to hear the sound. When a sound enters the ear in the form of vibrations, the eardrum vibrates. The vibrations then reach the inner ear, from where they finally reach the brain, and we are able to hear the sound.
So that's all about how we are hearing sound. Now, are you all clear how we are hearing sound, the process through which we are hearing sound?
Yes.
Yes, sir.
Yes, sir.
Okay, fine. So, and one more thing, we have seen that I will share my screen. We have seen that regarding this activity 13.11, I have another video showing this activity to you. Okay, here we are doing this
Okay,
activity
sir.
31, just vibrating that glass tumbler. And one more
Okay,
thing,
sir.
we are suspending a thermocol ball, attaching to it. And how this thermocol ball is being moved due to the vibration. And we have seen in our last class about the what about the tuning fork. Do you remember? The two arms are vibrating, and how the sound waves are being transferred. Do you remember the tuning fork? Don't worry, I was telling that because we are again using that tuning fork, how sound is produced from this tuning fork, and how this the vibration produced by the tuning fork affects this thermocol ball movement. So it will be recommended to use a headphone or headset to hear the sound clearly. Okay, if you want to hear what is the sound produced by a tuning fork like that. That's why I'm saying this. Okay, so it will be preferred if you use your headset or headphone like that. So I'm going to show you another video showing the tuning fork and this thermocol ball movement. Kindly use your headset as well, and don't put it in a higher full voice. Okay, use it in a minimum voice because this sound can be little bit uh, what maybe irritating for you, maybe. So don't use it in a high voice, high volume. Use it in a lower volume. Okay, are you all ready?
Okay,
So
sir.
so that I can share my video. This is a tuning fork. Okay. Many thermocol balls are there.
Okay, sir.
And another rubber space is there. It is through which we are hitting this tuning fork with that rubber box.
Okay, sir.
We are going to suspend this thermocol ball. That's why we are taking all that, and these thermocol balls are shown to you. We have suspended this thermocol ball. It is actually a 512C tuning fork, which means it can vibrate 512 times per second. We have seen in our last class what is the frequency. Okay, we have seen that frequency means the number of vibrations per second. So a 512C tuning fork means it can vibrate 512 times per second. Okay, when it is being hit with a rubber pad. Let us see. Listen carefully. That is the sound of tuning fork. See the ball is being vibrating. It is moving due to the vibration. See here. See, the first two movements are very much higher, but it comes to the later, it gets decreased as well. Listen carefully. We are showing in this experiment that when a body or this tuning fork produces sound, when one of its edges touches the table is also vibrating with that sound, so that we know that when a body vibrates, it produces sound. So when the tuning fork vibrates and when we touch it with the table is also starts to vibrating in the manner of that tuning fork, so that we can hear the sound in a louder way. That's what we are doing in this experiment. Okay.
Okay, sir.
So now we have seen this experiment, this experiment, that this thermocol ball gets displaced in the first two waves, but afterwards it gets decreased, which means when the vibration decreases, the movement of the thermocol ball also gets decreased. Okay, so now let us move to this where we have seen in our last class. So now we will move to the next section. The frequency determines the shrillness or pitch of a sound, which means we can say that if the frequency of vibration is higher, we say that the sound is shrill and has a higher pitch. You know what's a frequency? It means the number of vibrations made per second. It means If we have a higher number of vibration, then we can say that the sound is said to be in a shrill and it has a higher pitch. And what is pitch? It is the frequency that determines the pitch of a sound. I will explain to you what is pitch. If the frequency of vibration is lower, we say that the sound has a lower pitch. For example, when we see this example, you will get familiarized with what is the term pitch means. A drum vibrates with a low frequency. Okay, that is low frequency, which means low pitch. Therefore, it produces a low pitched sound. You know what is the sound of a drum? Okay, you know that you can remember the sound of a drum, and it means that sound is being produced by the drum is a low pitched voice, low pitched sound. Okay, now on the other hand, a whistle has a very high frequency and therefore it produces a sound of higher pitch. A figure is being shown to you. See, you know that what do you mean by pitch? It is the frequency that determines the pitch. See, when we see the drum, see, if we can see that this is a wait. When you move to higher classes, you will learn by seeing a wave, sound wave. You will learn how we can represent how many vibrations are made in second. Just by seeing that, we can see that in 1 second, this wave or this drum produces 4 vibrations. Say suppose 4 vibrations are made, which means in 1 second this drum vibrates 4 times. But when we come to this whistle, then we can see that the frequency of this the sound produced by the whistle is much higher. In other words, the number of vibrations that a whistle produces is 7 or 8, a bit larger, a much larger or double than that of the drum. That's why we are saying a whistle has a very high frequency. Now, another examples are also given. And one more thing, keep these examples in your mind, okay? Because maybe for exams, you may ask, give an example for a high pitched sound or a low pitched sound. Not this exam, later exams, okay? All of you clear? Shall we move further?
Yes, sir.
Yes.
Okay. Now, a bird makes a high-pitched sound, whereas a lion makes a low-pitched roar. However, the roar of the lion is very loud, while the sound of the bird is quite feeble. Again, in everyday life, you may hear many sounds. Even you are hearing, now you are hearing my sound. You can see that, or you can you say that if the voice of a child is higher than that of an adult, an infant's voice, does it have high frequency? We shall see later. Okay. And one more thing, usually the voice of a woman has a higher frequency than that of a man. Okay, that's why men or boys and girls are having different voice. You may think, some of you may be having doubts why her sound is different than that of mine. This is the reason, because the voice of woman's voice have higher frequency than that of men. Are you all clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now we are going to section 13.6, which is audible and inaudible sound. Which means audible means we can hear, inaudible means the sounds that we cannot hear. Is there
We cannot hear.
what? Yes, you may be thinking there are do you thinking that there are sounds we can't hear? Is there any sound we can't hear? Of course, there are lot of sounds which humans can't hear. We will learn that in this section. We know that we need a vibrating body for the production of sound. But can we hear the sound of all vibrating bodies? Here asks the question. The fact is that sounds of frequencies, remember this is very important, less than 20 vibrations per second, that is 20 hertz, cannot be detected by the human ear. Such sounds are called inaudible. On the higher side, sounds of frequencies higher than about 20,000 vibrations per second, that is 20 kilohertz, are also not audible to the human ear. Thus, the human ear, the range of audible frequencies is roughly how much? It is from 20 to 20,000 hertz. Which means we humans can hear only sounds ranging from the category 20 to 20,000 hertz. You may, I will give you an example. You may see when you are about to buy some headsets from online or in a store, look for the descriptions. Then you can see that for some high quality headsets, they show the frequencies like 20 to 20,000 hertz. High quality headsets are giving the full capability, are making use of the full capability of our ears. But low-end headsets are using only, they may be using like how much we can say 100 to 20,000 hertz. But high-end headsets, you may go through the descriptions of just go and search some headsets, the cover of the back cover of the headset, you can see all this information. This one, especially this one, I'm going to highlight it again. 20 to 20,000 hertz. That is very, very important. Okay, keep this in mind. Some animals can hear sounds of frequencies higher than 20,000 hertz. Dogs have this ability. The police use high frequency whistles, which dogs can hear, but humans cannot. Okay, that's why sometimes we may not hear any sound, but the dogs in our house starts barking. You know why? Because they can hear the sound. Because according our human ability for hearing sounds lies between 20 to 20,000 hertz only. A sound higher than 20,000 hertz and a lower than 20 hertz we cannot hear that. Okay. And again, the ultrasound equipment familiar to us for investigating and tracking many medical problems works at frequencies higher than 20,000 hertz. Okay, like in our hospitals, we can see that ultrasound scan, like that many type of scans are there. And actually there is many sound is produced, but we humans can't hear that. Okay. Are you all clear with the section audible and inaudible sounds?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
So now we are
Yes,
going
sir.
to, okay, fine. So now we are going to noise and
Noise
music.
and music.
The word itself describes, you know better than me, what is a noise. A noise means the sound produced by all of you during an interval. That's a noise. Because we can't, no one can, only when we when if one of you come to the out of the classroom and just try to hear what sound or what are your friends saying, then they can't hear anything properly. Only some sounds. That's why even if we can hear, we cannot understand that. Okay, we shall see what is noise, the definition. We hear different types of sounds around us. Is the sound always pleasing? No. So does a sound sometimes cause discomfort to you? Some sounds are pleasant to the ear, whereas some are not. Some construction work is going on in your neighborhood. Suppose, okay, are the sounds coming from the construction site pleasing? You may see that it may be irritating for you. You will get headache if you hear very high voice. Okay, you are being asked some questions also. Do you enjoy the sounds produced by horns of buses and trucks? Such unpleasant sounds are called noise. Okay, in a classroom, if all the students speak together, when um, all of the students in our classrooms speaks together only in the interval, what would be the sound produced be called? That is the sound produced. We can say the sound produced is
Noise.
a noise, yes. Now, on the other hand, you enjoy sounds from musical instruments. During the beginning of this chapter, we have seen many equipments, many musical instruments. We have seen it. So the
Yes,
sounds
sir.
produced by these instruments are very very amusing to our ears. Okay, they are pleasing. Let us see. Musical sound is one which is pleasing to the ear. Sound produced by a harmonium is a musical sound. You can see that. The string of a sitar also gives us a musical sound. But if a musical sound becomes too loud, would it remain melodious? No. You can do this by yourself in your home. Just listen and take a headset or just take a headset and put it in your ears and just play your favorite song. Then gradually increase the sound of your device. Let it be a system or a mobile. Gradually increase the sound. What you can feel? Your favorite song gets irritating to you, or it may become a noise to you. Okay, which means is the sound, even if the music is even if it is a melodious or a pleasing sound, even if its sound is very higher, then we will feel it to be disturbing also. Okay, so you know exactly what is the difference between a music and noise.
Yes,
Okay,
sir.
fine. Now section 13.8, noise pollution. You have already known about what is air pollution. The same thing goes to I mean noise pollution also. The only difference is here we are having noise, but in case of air pollution, we have air, but here, that is in noise pollution, we are dealing with the sound. Okay, let us see what is air pollution. Presence of unwanted gases and particles in air is called air pollution. Similarly, I am using a different color. Presence of excessive or unwanted sound in the environment is called noise pollution. This is the definition for noise pollution. Okay. The presence of excessive or
Excessive
unwanted
or
sound
unwanted sound
in the
in the
environment.
environment
Okay, by heart this.
is
You may
called
be asked, you may ask for exam, what is noise pollution? A simple, easy question. You can score full mark just by knowing the definition only. Now, you are asked a question. Can you list some sources of noise pollution? Can you tell uh, what are the sources of noise pollution?
Sound of bicycles, explosions including bursting of crackers, machines, loudspeakers, etc.
Yes, you have seen
Sir,
many. You can say that the sounds of vehicles, there are some vehicles producing so much noise. Then what? Explosions, including bursting of crackers, then some machines are there, then loudspeakers. These all are sources of noise pollution. Okay. And television and the transistor radio at high volumes, some kitchen appliances, desert coolers, air conditioners all contribute to noise pollution. All you should keep this in your mind also, because these are the examples of noise pollution. You may be asked for, maybe not for today's, no, not for exam. Okay, I'm
Okay,
saying
sir.
about for your next exam, you may be asked that what are the
Okay, sir.
sources of noise pollution, or give some examples causing noise pollution. Okay, now what are the harms of noise pollution? What happens if what are the harms of noise pollution? If this noise pollution increases, what happens to us? Let us see. The presence of excessive noise in the surroundings may cause many health related problems. Okay, especially lack of sleep, hypertension, which means high blood pressure, anxiety, and many more health disorders may be caused by noise pollution. A person who is exposed to a loud sound continuously may get temporary or even permanent impairment of hearing. That's why you know that in war, in our army, they are using stun grenades like that. Do you know what does a stun grenade do? When we throw that grenade, it just explodes, and the sound, we won't get any physical harm is not produced. That we may not bleed, but the sound produced by that stun grenade creates disturbance in our uh, ear, and we may be not able to hear something for some second. During that time, we may attack like that. Okay, you have already, you may know that all of this. And health related issues, lack of sleep, that is a main problem. If you may have already faced this in your home. Due to high or noise pollution, some you may lack sleep, that will lead to high blood pressure and anxiety and many other health disorders. Okay, now how we can limit this noise pollution? To control noise, we must control the sources of noise. First of all, we have seen what are the sources of noise in the previous section. So we must control that sources first of all. Then how can this be achieved? Let us say, for this, silencing devices must be installed in aircraft engines, transport vehicles, industrial machines, and home appliances. We know that the sources of this noise, and we have to insert what we have to install. We have to install silencing devices so that they produce a low
Silencing
sound.
device.
Yes, so that they produce lower sound. How can the noise pollution be controlled in a residential area? Let us see. All noisy operations must be conducted away from any residential area. That's the first of all thing. Then noise producing industries should be set up away from such areas. We know that in some industries, there obviously whatever we try to do, there are some high sounds will be there. Even if we install some silencing devices, also still there may be high sound. In such cases, what should we do? Such kind of industries should be kept far away from residential areas, so that it may be situated in a remote village or like that. Okay. Now, use of automobile horns should be minimized. You may have noticed that near to the or hospitals there may be a board showing avoid using horns. Have you noticed? Have anyone seen that? Near to the hospitals we can see avoid using air horns like that, because these air horns will produce a noise, and we know that in hospitals there are many people suffering from many diseases. This, even when this noise pollution also increases, they may find it very difficult, okay, to try to through that disease. That's why it is written in a board, avoid using air horns. Now let us see. TV and music systems should be run at low volumes. The next one, trees must be planted along the roads and around the buildings to cut down on the sounds reaching the residents, thus reducing the harmful effects of noise pollution. Okay. So that's how we can measures to limit noise pollution. And you have one more thing, hearing impairment, that you can read by yourself, and if you have any doubt you can ask me. And one more thing, now you can do the exercises. Since today is your exam, I will say when to submit this exercise. Okay, in our next class you can submit this exercise, okay, completely.
Okay, sir.
Complete these exercises and submit in the next class. That will be after some days, I think.
Okay, sir.
Okay, so I'm stopping my screen share. And do you have any doubts regarding our today's class?
No, sir.
No,
No,
sir.
sir.
Okay.
No doubt.
Okay, so study well, prepare well, and perform the best in your exam. Okay.
Thank you, sir.
Okay, sir.
Okay, sir.
Okay. You all clear about the portion also? Again, some students are asking,
Yes,
that's
sir.
why I'm asking. Chapter 11, friction as in force as not friction, force and pressure. Okay. First chapter only.
Okay, sir.
Yes, sir.
Fine. So I am ending the meeting. Thank you.
Okay, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay.
Thank